morning, good afternoon, good evening, whatever the case may be. We are back and better than ever, and we are on our sixth part regarding binary operations. And today we are going to behold the Cayley table. Yes, we are going to construct Cayley tables, and we will say behold the Cayley table after we construct one. Because of the great Nafisa Chaudhry, a Laker alum, she made a Cayley table, was demonstrating it in front of the class, and out of nowhere, she said, after she had completed the Cayley table, behold the Cayley table. Let's get to it now that I've piqued your interest. Cayley tables are named after Arthur Cayley, and we construct them it's very simple. We just perform the operation, and it's like your multiplication tables. Whatever the operation is, we list the elements here, the same elements here, and we operate, and the result is at the intersection, just like in your multiplication tables. So the best way to show you is just to give an example. So let's binary operation on S equal to 0, 1, 2, 3 be defined by A star B equals A squared plus AB. Construct the Cayley table for the binary operation. So let's go ahead and list our elements 0, 1, 2, 3, and then 0, 1, 2, 3, and then we'll do, let's see how straight I can get my lines. And we're going to make a little table just like we made our multiplication tables. Boom, jugga, lugga, lugga. And here we go. Here we go. I probably should make it a little bit nicer like that, if we're going to indeed, you know what. Boom. Boom. Ooh, I'm getting fancy. I'm going to make it a nice little box. All right, and we put our operation, which is star. Now, just make sure that you do not think of this as multiplication, because remember, A star B, I'll put it up here so we can refer to it and I don't have to go all the way over here, is equal to A squared plus AB. Okay. So 0 star 0 is going to be 0 squared plus 0 times 0, which is 0. So 0 squared plus 0 times 1, 0. 0 squared plus 0 times 2, 0. And 0 squared plus 0 times 3 is 0. If you haven't figured it out, these are all my A's, right? Oops. These are all my A's. And these are all my B's, okay? Okay, so for 1 squared, for 1, 0, 1 squared plus 1 times 0 is just 1. So 1 squared is always going to be equal, or it's always not equal. 1 squared is always going to be 1, so it's always going to be 1 plus 1 times B. So 1 times 1 plus 2, or 1 times 1 is 2. 1 plus 1 times 2 is 3, and 1 plus 1 times 3 is 4. Okay, so here 2 squared plus 2 times 0 is 4, because 2 squared is 4. So again, we're always going to add 4 to 2 times the element. So 4 times 2, or plus 2 times 1 is 6. 4 plus 2 times 2 is 4 plus 4, or 8. And 4 plus 2 times 3 is 4 plus 6, or 10. And then we have 3. So 3 squared is 9 plus 3 times 0, so that's just going to be 9. So it's always going to be 9 plus the product of the 2. So 9 plus 3 is 12. 9 plus 6 is 15. And then 9 plus 9 is 18. And of course, you could have seen the patterns there and just worked it out real nicely. So we are done, and we are going to say, behold the Cayley table in honor of Nafisa. All right. So that's so we did that. So A. Oh no, that is part A. B is the operation closed on the set S. Well, remember, if it's closed, when we perform the operation with our elements, of our set, we must, if it's going to be closed, every time we do that, the answer has to be one of the elements of the set. So is that true? Well, no. I mean, right away, like here, we can say 2 star 1 is equal to 6. So right there, since 6 is not an element of S, we can say no. Now, they just said, is the operation closed on S? So our answer is no, but I'm showing you why. Now, is the operation commutative? Well, remember, what are they asking? Does A star B equal B star A for all A and B which are in the set S, which are elements of S? Well, let's take a look. 1 times 0, or 1 times, there I go. 1, 0 is 1, and 0, 1 is 0. So right away we have a contradiction. Look at this. 1 star 0 is equal to 1 right here, right? And then 0 star 1 is equal to 0. So right there, the answer is no. Now, there is a much easier way that I'm going to show you. And that way is to take a look at what is called the main diagonal. It's a lot quicker. So I'm going to draw the main diagonal using my line tool. And the main part of the Cayley table is here, where you've done all of your operations. It doesn't include the elements of the set. So I'm going to start here and draw my main diagonal here. And if the main diagonal is symmetrical, or if the table is symmetrical about the main diagonal, then you know that the operation is commutative. And we'll see that in the next example that I do more clearly. But it's not commutative. 12, 8, 4, there should be a 12 here. These two numbers should be the same. And if it were symmetric, then this would be 9, 6, 6, 9, or from this direction, 0, 3, 3, 0. But it's not symmetrical. And if you go through and do all of the possible combinations using the commutative property 1 plus or 1 star 2, 2 star 1, you would see that it would come out symmetrical. So I'm going to stop there. And this will just be the first part of this, and we'll continue with Cayley tables, and we'll see how days go by. Hope you enjoyed it. I am out.